Okay, so welcome to this workshop, Reinforcement Learning Application in Financial Trading and Investment. So this is a workshop out of the series of workshops we are holding in January, the AI Application in Finance workshop series. My name is Abubakar Sani Ali, and I will be guiding you through the workshop. As a disclaimer, what we're going to discuss today is strictly for educational purposes and not for uh, not a financial advice. Okay, so if you want a financial advice, I will advise you to seek a financial advisor. All right, so the agenda for today, I will start with an introduction, after which I will discuss the basics of machine learning. Okay, then I will discuss neural networks that form the basis of deep reinforcement learning. But before that, I will also discuss a little bit about the basics of reinforcement learning. After which, we will discuss how we can develop a strategy that is based on neural network first. And in the subsequent sessions, we will see how we can now integrate our strategy into deep reinforcement learning. Then we will see how this strategy can be used, okay, to build a trading bot via our trading bot building framework. We will build the trading bot live, after which we will open the session for Q&A. So for the introduction, my name is Abubakar Sana Ali, and I welcome you to this workshop. Uh, as a little introduction of myself, I come from an engineering background. I studied electrical and computer engineering during undergrad, and I pursued my MSc in communications and signal processing. After which, I did my PhD in electrical and computer engineering once again, with a specialization in machine learning applications in communication systems. Uh, this institution that is organizing this event is called Asatora Services, and we provide different services which include consulting services in the fields of AI, IoT, and cybersecurity. Not only that, we provide trainings and workshops, and you are present in one of those workshops today, so you are very welcome. We also do research and development, so we work together with institutions to work in research related to AI, communications, IoT, and stuff like that. So, what do we intend to get out of this workshop today? First of all, we want to understand the basics of machine learning and how it is used in trading and investing. Then we will see some case studies that have been used, okay, that have used machine learning to develop trading strategies. After which, we will build and implement a trading bot using neural networks, which is the basis or the brain of deep reinforcement learning. So to start with the machine learning, for those who are joining this session for the first time, I will give an overview first so that you will have a context of what we're going to discuss afterwards. So when we talk about machine learning, we are talking about a subset of artificial intelligence. So artificial intelligence happens to be the umbrella. So we have so many different types of AI techniques out there. All right. And these come in different shapes, evolutionary computation, robotics and stuff like that. So machine learning is just one of those fields. And a subfield of machine learning is called deep learning. So in the previous week, we've discussed some machine learning techniques. Today, we're going to look at some deep learning techniques, and not only today, for the subsequent weeks of January, we're going to look into deep learning approaches. So what are machine learning techniques? So these are techniques that tend to learn from experience. So if you have any technique that tries to learn from experience, from history, from data, this system is termed as an AI system. okay, that uses a machine learning uh, process to learn. And the idea is we want the system to learn from that history without us having to explicitly program the system to be doing what we want it to be doing. That's the idea. And some of the applications you are used to and you've come across include email filtering. And this is where your application, your Gmail, uh, if you open your Gmail app, you will see that you have different folders. Each folder is containing different type of email. So that kind of classification into inbox, into, you have primary inbox, you have promotions, you have social, all this is done by a machine learning or AI algorithm behind the scenes. Speech recognition, Siri, Cortana, Alexa, all these systems are currently powered by an AI or machine learning technique. Predictive analytics, this is something we're going to see today. This is how we predict what is going to happen. Okay, so given some information, given some trend, what do we think is going to happen in the coming future or now? Okay, and you can have different applications in healthcare, for example. We want to see, we want to predict what is going to be the right medicine for a patient. In finance, for example, in banking industry, they want to give like credit score to people and their customers, so they can also do this to predict. Okay, given your history, what will be your credit score? Retail, they try to use customer insights to make uh, more informed and improve their sales. And one of the real life case study, okay, was the case of Target. So if you check this Target case study, it's very popular, happened in the US. Target were using data mining algorithms to mine the data that relates to the consumer or customer shopping pattern. Based on what you are buying, they tend to understand what is your current situation, and they start targeting you with flyers that are personalized for you and your issue. So they sent these flyers to a lady who happens to be pregnant, but then her dad was the one who received the email, only for him to go and complain to the manager for him to learn that his daughter was pregnant. So the AI knew that before the father knew. Data science was used by Obama during his 2008 and 2012 election cycle, and that helped him to greatly mine the data of Facebook users to help him win the election. So machine learning come in different shapes, or in terms of the tasks that you can use machine learning to achieve and accomplish come in different shapes. And these are what we call supervised learning, unsupervised learning, and reinforcement learning. Starting with the supervised learning approach, we are talking about a system where you have a teacher or a supervisor who is there trying to teach a student how to solve a particular problem. Okay, so this teacher will bring so many problems, examples, exercises, display this, showcase this to the student with their corresponding solution and answer. So this way the student will be able to learn using under the guidance of the teacher. Unsupervised learning approach, however, here the student only gets data from the teacher, examples, no answers, no solutions. And what we expect from the student is to try to learn how things work, how things connect. The enforcement learning in this case does not even have access to data. So there is no data for enforcement learning. Learning occurs by trial and error. So the machine learning algorithm that learns through trial and error, this kind of algorithm are what we term as reinforcement learning algorithms. And supervised learning comes in two shapes mostly. What we have the regression. So this is when we are predicting a continuous number, for example, stock price, house price. All these values are continuous. Weather, you know, what's going to be the weather tomorrow. So we are trying to predict a continuous value. What the credit score of a customer, a continuous value. Classification comes as a way of predicting categories. So either yes or no, true or false, cat or dog, or even multiple classifications. You can say, okay, you have cat, dog, horse, lion, cow, and so on. So this is classification where you put things in categories. You have unsupervised learning, as I said, doesn't have the date, the label. So you only have access to information, but you don't know. If I give you an image of a cat, you can't tell that this is a cat or this is a dog. But one thing you can do is to say, okay, these images look similar, so we will put them in one part, in one place. These other images also look similar, most likely belong to the same category. But the name of the category, I don't know. So this is like a clustering algorithm or association. You try to find how things work together. We have what we call the data reduction or dimensionality reduction. Here we tend to reduce the number of features. For example, let's say if you are trying to figure out the price or the price of a house, and you have so many things to take into consideration, so many variables, so it becomes maybe difficult for you to come up with a decision. But if I reduce the variables for you to decide to maybe two or three, size of the house, the crime rate in the neighborhood, as well as the age of the house, maybe with these three information, figuring out the value of the house will be a lot easier. But if you have so many different data, it becomes difficult. That's where you can say, okay, why don't we reduce these features from maybe 20 to just three, that can make life easier for us. And it has been used in investing and trading machine learning. For example, it has been used to enhance predictive accuracy. So normally, if you are trading or investing, you are trying to make prediction or forecasting. You are forecasting, right? That you are forecasting a stock price or an asset price is going to reach a certain value, a certain level. That is your forecast. Okay? You might come up with this forecast based on different reasons. Maybe you saw maybe some news, okay, that made you make that prediction. So with machine learning, it will be able to use so much historical data to further help you in making that decision. Okay, so these are some of the ways that it is used. We use it a lot, especially in price prediction. You use machine learning a lot. Not only that, risk management. Let's say I see a good opportunity and I believe that this is a good opportunity. But the question is, should I invest all I have in this opportunity? It's Bitcoin. Should I put all my life savings in Bitcoin? Or how many percentage of my life savings should go into Bitcoin? So this kind of approach, you know, how do I manage? How many coins should I buy? All this. So this you can also use machine learning to tell you, okay, based on the historical information, yeah, maybe I will recommend you to use maybe 5%, 2%, 3% of your total life savings. That will help you save money and you will not fall into you know yeah, we have seen lots of case studies where people put all their life savings and then they fall into a lot of trouble. So we don't want that to happen. So machine learning can help with that. Okay. And as I said, big guys have been using this in Wall Street. These are all big names. If you go to Wall Street, these are all big names. Renaissance Technologies, BlackRock, Citadel, Charles Schwab, JP Morgan, all these are big guys. And they have been using AI and machine learning. All right. And the idea is to see how they will automate and have data, historical data, because for them, they have huge amount of data. You know, they have been at this thing for, let's say, hundreds of years, 200 years. So they have all this huge data so that they can be able to start figuring out some pattern in the data. And that's some advantage they have. Okay. So now we are going to talk a little bit about neural networks. I've talked about machine learning in general, and I have made mention of deep learning earlier. So neural networks are those techniques that form what we call the deep learning techniques. Okay, so these techniques are based on neural networks. And why do we call them neural networks? Basically because they got their inspiration from the neurons in our brain neurons. Okay, so if you look at this, uh, figure here, this is a simple picture of one single brain cell, okay, or brain neuron. So this is how it looks like. You have these dendrites and you have the nucleus, and then you have the axon and you have the boutons. So normally signals come via the dendrites, and then it will synthesize some of information. Then it will try to see, should I pass this signal through to the next neuron, because all these neurons are interconnected. So the others are interconnected via the button, so it will pass it through, and then the other signal will also see it, and then it will see, should I fire this up? So this is how they work, okay? So this is how our brain work, and neural networks try to mimic this operation so that it try to see so many information, that basically will be very hard to model mathematically, but this one will now be able to have all these interconnections, and then at the end of the day we'll be able to make predictions. So why neural networks? First of all, we want to have the ability that human beings have, which is called pattern recognition. Okay, we humans, we are incredible when it comes to pattern recognition, because our brains process inputs from the world, categorize them. you know you see an image, you see, an object, you say this is a spider, this is an ice cream, and stuff like that. And then once we know this, we come up with an output. For example, if it is a child who sees a spider, he might decide to run away. Or if he sees an ice cream, he would like to take a test, have a test. So this is something, we see some pattern, we take action. Okay, and we do this automatically and quickly with little or no effort. Nobody has to put in any effort to do these things, right? So this is the same way that system sense that someone is angry at us. Okay, we are using the same system. If you are talking to somebody and he's angry at you, you use the same system to tell that, okay, somebody is not happy with me. Okay, we do all this. You know, we see the stop sign while we are driving. We just stop. Maybe sometimes we are not even aware. Sometimes, if you are an expert driver, you start driving from work and you reach all the way home without any idea what you have been going through while you are driving. So many times this happens. All right. So this happens a lot. So this power, this super power that we have as humans, that is what we try to mimic, and build using these neural networks. And how do they work? Now look at what we call a simple perceptron. Okay, this is how we take it. If you remember, I showed you the real thingy. This is a a neuron, a brain neuron, right? A cell in the brain. This is, for example, how a neuron in the brain looks like. And look at this. This we call it a perceptron. You can see this. You can see these are the dendrites. This is the nucleus, for example. You know, so you can see dendrites, nucleus, for example. Then the long, the long part pipe will be the axon, and then the output is the boutons. So this is how, like, we try to model those brains in this, and this we call it a perceptron. A perceptron. Okay, so this is a single unit of a neural network. Just like you saw that neuron is a single unit, okay, or a cell is a single unit, okay, of the brain. Here too, a neural network will have a single perceptron. So you will have one single cycle like this, and it will have all these connections coming in. Then you will have this nucleus that does the function. Okay, just like here, the nucleus that will do stops, then decide whether to fire or not. Whether to pass along the information or not. Okay, and that's what these things do. The sum and the activation function. So basically, what you are saying is all those weights, this we call them weights, okay? The weights determine how, like, how powerful this signal is from this particular input. Okay, we have, let's say, n inputs, and input one is more powerful in terms of, uh, signal strength compared to signal two. So we need to know the weights. Even
Right.
though we have n inputs,
Look in
we want to also know what are the weights of these inputs. Okay, so this is the idea. So once you have this idea, you get this, you will sum and multiply everything. And then we have what we call the activation function. Okay. So the activation function tries to tell us when should our neuron or nucleus fire. Are we going to fire anytime we get receive a signal, or are we going to wait? So we set a threshold, okay, and we fire when our signal reaches that threshold value. Only information that is important should go through, something like that. We don't want to have our brain processing every little amount of information. Okay, so this is how it works. It sums up all the weights of those inputs, multiply them up, and then it adds something we call the bias. Okay, so this is what we call the perceptron, and the activation function here, okay, is once we get this, which is the output, let's call it y. But this y, if the information is very negligible, it doesn't have any value, you know, becomes minus infinity, for example. Or if it is of significant value, significant importance, you can say this is plus infinity. So we don't want values in that regard. So we try to constrain our values maybe between 0 and 1. We don't want values to run all the way to minus infinity or to run all the way to the positive infinity. And that's where the activation function comes. That's why it is attached to the front of the summation. So you put the summation, you do all that, and then you pass it via activation function, where the output now is constrained into a certain limit. And you get it. You get an output between 0 and 1, which is reasonable and easier than to get things between minus infinity and plus infinity. Okay. So we talked about perceptron, which is a single cell. Okay. But what happens if you have many of them? So here, for example, you can see how many cells: 1, 2, 3, 4, 5, 6, for example. Okay. This one here, we have what we call a multi-layer perceptron. Okay. So as you can see, you have 3 layers here. 1, 2, 3. We call this a multi-layer perceptron. Here is a single perceptron, just one single thing, one single unit. Okay, but here you have that one single unit. This is it here. Okay, and this is the single unit here, and you are connecting all these inputs to this one single unit. Then you have another unit also is connected to all of these guys. You have a third unit also connected to all of them, all the inputs. You have the fourth unit also connected to all the 4 inputs. Okay, so this is, let's say we can say 4 units. Okay, 4 units, or you call it neurons, right? 4 neurons. Okay, but this here we call it the input layer. Okay, that's why you see it input layer. The layer in between, we call it the hidden layer. And then the last layer here, we call it the output layer. This is the layer that outputs or gives you an information or prediction. For example, let's say I'm trying to predict 2 things: the stock market or the stock price of a certain asset, let's say Amazon. Okay, I want to know that. And I would like to also know, okay, maybe what should I predict again? If I predict the price, maybe let's say the percentage increase, for example. Okay, that is going to happen. Okay, so I'm getting 2 things out. So this is my output. So this hidden layer can come in different layers. So this we call it multi-layer perceptron or multi-layered neural networks, because you have all these neurons. Okay, so having them connected is what you call the neural networks. Okay, and then of course they all take in inputs. They all share the same inputs. All of them take in the same inputs. No skip. So this is a non skip. That's why we call this kind of network fully connected neural network. Everything is connected to everything else. Okay. So now that we have this, if we pass information from the input and it passes through all these neurons, firing here, firing there, till when they go to the output, we get some information. For example, the price prediction. We got the price prediction. But the question is, how do this, because these neurons are tuned, it's like having a radio. If you know radio, for those of us who grew up during the radio era, you have a radio, and I know many of you too have it in your car. You tend to tune the frequency to reach the certain channel you want to listen to. Okay, so that tuning process is what allows you to get to the value or to get to the right frequency, right? By tuning the frequency, and that's something we do here too. We have to tune these neurons because by default, when you start them up, they start with random values, okay, inside them. So these random values will be giving you very poor prediction, okay, very poor prediction at the start. But then you want to tune these values inside that are inside this, you know, and the weights here, because I told you we want to put weights to things that are good. For example, if I know something is very important in determining the stock price, I would like to give it more weight. I will tell the network, focus more on this. Okay, don't waste your time on this. This is negligible. Okay, but this one is very significant. So focus, put more weight. And that is what we call the tunable parameters. Those weights, okay, you can call it order of significance. So we call them tunable parameters, the weights. We are putting weights. We are telling, okay, put more importance, more significance on this input. So this is the process of doing this tuning until when we get the right frequency, okay, for our neural network to be giving us the right output. Good prediction is what we call back propagation in the context of neural networks. So it allows us, once we make prediction, we get our output, then we propagate this output back into the network, and then we calculate an error. What the error? The prediction here, maybe let's say it is predicting 200 as the stock price of, let's say, Amazon in the next 20 minutes or 30 minutes or 1 hour. But then once the hour comes, the price is what? Let's say 300. So you can see the error is around 100, right? So we want to be able to have prediction that will be giving us as little error as possible. So if possible, let's say our prediction should be equal to the ground truth, okay, or the original value or the target value. So the process of that tuning is what we call back propagation. Under it, there are so many things involved. We have what we call the gradient descent, which performs optimization to reduce that error and stuff like that. So this is a little bit of a primer about neural networks. Okay, so the next thing I would like to discuss about is the reinforcement learning. Of course, as I said earlier, or the title of the session is Reinforcement Learning Application in Financial Trading and Investment. So I gave an example earlier that in the case of supervised learning, you have a teacher, he comes to the student with images, right? Examples of images, and he tells it, okay, this image is of a cat, this image is of a dog. So this cat, this dog, cat, dog, until when the student understands the pattern. So okay, I see. So a cat has whiskers, has pointed nose, for example, or ears, has fur, has this, has that. Okay, I see. A dog has this. This is the average size of a dog. Stuff like that. Tries to understand all these features of dogs and cats so that it can be able to differentiate. Okay, that's how we teach in supervised learning. In the case of reinforcement learning, no teacher that will be there to tell you this is cat, this is dog. So what happens is we will allow the student to go. I will tell him, when you see an animal, tell us the name. Okay, there are 3 names. There is cat, there is dog, and there is lion. So when you see an animal, just make a guess that this is a cat or dog or lion. So at the start, whenever he sees maybe an animal, this student will say dog. Everybody is dog. Everything is dog. Then when he said dog and he got it right, that yeah, that is specifically a dog, we give him a reward. Maybe ice cream. But when he calls it a dog, but it is a cat, we penalize him by denying him an ice cream. Tell him no ice cream for you. You got it wrong. Okay. So Let me try to tune my parameters so that the next time I see this, my certainty of it being a dog should be less. So it keeps doing that, keeps doing that, keeps doing that, and that's how it lands a dog and cats, how it differentiates them by doing trial and error while getting rewarded in the situation or in the process. Okay, so this has been implemented in so many different scenarios. For example, they have implemented it to play chess and it was very good. It actually beat one of the top guys. Of course, we will talk about that later. For checkers, okay, they have what they call AlphaGo. That's the thing that beats those big Go players. Ping pong too. You put uh, the agent there in a simulation environment and it plays ping pong. It lands on its own. You have animals. Okay, for example, you can have an agent to simulate an animal where if the animal doesn't go out to hunt for food or doesn't perform a well, you know, a good behavior, it is starved. So by getting starved, it becomes hungry and it feels the pain. So it realizes this is a negative reward and it tries to avoid that negative reward so that it does the things that it's supposed to do so that it gets what food intake. Okay, so this is the reinforcement learning. There are so many different algorithms under it. We have the sarsa, we have what we call the q learning approaches and stuff like that. So many of them, multi-arm bandits, key-arm bandits, and what have you. Specifically, we are interested in the deep reinforcement learning. Okay, so this technique of trial and error with a reward, okay, was employed in a process and it was integrated with the neural networks. So imagine having that powerful system where you allow something to go and learn by trial and error, and then you give it a human brain. So it will learn faster, right? And the human brain I'm talking about here is like the fake version of it, of a neural network. Okay? So you have a neural network as the brain of the agent. So the agent is embedded with a neural network to be able to learn how to do the right things and avoid doing the wrong things. And that's where the deep reinforcement learning comes into play. So if you hear reinforcement learning, is this concept of having trial and error approach of learning. But when you hear the word deep added to the reinforcement learning as a prefix, then we are talking about that same process of trial and error, but then the learning algorithm is a network, a neural network. Okay, this is a very good example. This is important. This we call them the elements of reinforcement learning. So when you are trying to learn, okay, the idea is to train this agent. In this case, let's call the dog the agent. Okay, that's the thing that it's trying to learn. So when it comes to this, whatever, for example, in your case of, let's say, financial investment or trading, your agent is what? That thing that is making decisions of buy or sell. That is your agent. Okay, so the thing that has this power of buying and selling is the agent. And the environment, this is where this agent is interacting. What is it interacting with? In the case of financial market, it is interacting with the market, right? Just looking at things happening in the market. That is its environment. If you have, let's say, this dog, for example, the environment is what is happening, what it is seeing, what it is perceiving, the thing that will allow it to make decisions. In this case, what it is perceiving is what this young lady is doing. Okay, that's what it is perceiving as its input, and that's what we call the observations. Okay, so from the environment you make observations. So whatever this lady does will become the observation of the agent. And then once the agent makes an observation, he would like to take an action. Okay, so when he takes the action, if the action is good, he gets a reward. If the action is bad, he gets penalized. So these 5 things are what we call the elements of reinforcement learning: the agent, the environment, the action, the reward, and the observation. So the environment will give us the observation, the agent will take the action, then based on that, the environment will reward the agent. I hope this is clear. So this is what is reinforcement learning. And what I said was, when you bring in the deep into the picture, you are saying the brain of this agent, okay, is nothing but a deep neural network. So there are so many different brains systems you can have for the agent. But whenever we use deep neural network as the brain of the agent, then we call this a deep reinforcement learning. So whatever brain you want to use is up to you. But the one that is mostly used in the context of this is the deep neural network. Okay. And the main goal is to find a good policy. That is the main objective. That is our main goal. Is for this agent to find a good policy. For this case, the good policy will be the situation where if the environment throws the stick, the dog follows, gets it, and comes back. After it fetches it, comes back to the environment, and the environment reward it with a treat. You know, so that's a good policy. We want this agent to avoid the situation where the environment will throw the stick, and then the agent sits waiting or looking at the
Mm.
environment without following. That is not something we want. So that is a bad policy. Okay, so that is the goal. The goal is to find a good policy. In the case of trading, so the good policy will be the process where the agent is able to make right decisions by buying or selling a particular stock. That's a good policy. Okay, and when it buys, it really buys it and it gets profit out of the transaction. When it sells that stock and it still makes profit. But we don't want it to have a situation where it develops a policy that makes it buy, then by buying, it loses money. Okay, so this is reinforcement learning, and this is how it is related with neural networks. And as I said, so many applications. Initially, this deep reinforcement learning was used in the context of gameplay, and one of the first things that made it very popular is the AlphaGo contest. What we have the AlphaGo, where you have checker playing programs that were able to beat the Go champion of the world. And this is a very nice example. I Let me see if I can play this video. Okay. So this is Google DeepMind. So DeepMind, this is a company, initially a British company from, I think, University of Oxford. Yeah, from a research lab in the University of Oxford. So this research lab were the pioneers when it comes to research related to deep reinforcement learning. So they come up with this system. Still not going full screen.
Mhm.
Okay. So you will see that it will learn to play this breaking, you know, it is learning, it is learning. Initially, it was not doing well. It was falling, it was losing the ball. Then after some time of training, it start to master, and then it figure out a way. Actually, that's something very interesting I come to learn of. Figure out a way to create a tunnel. For those of us who have played this arcade game, if you were able to create a tunnel from the side, then the rock brick breaker will go up there and it will continue to be winning all the bricks, without you even having to move. You see, now it has sent it up there. It just keeps tunneling like this and it keeps doing that. So that was the best policy it came, and it achieved very, very high scores. When they developed it, it became a sensation. And that's when people started to get very, very interested in reinforcement learning, especially now that the neural networks was added into the mix. Okay, So now that we have a basic understanding of neural networks, reinforcement learning, and then all these things, we come back to one of our main goals of the workshop, that is to build a trading bot. Okay, so for those who have attended the previous sessions, you know that we have been following a certain framework when we are building a bot. So the bot could be for investment, it could be for long-term investing, it could be for short-term investing. If you are doing the swing, maybe you are a swing trader. If you are trading also, maybe scalping or day trading, depending on what you are doing. So this framework too, you can follow it, and then you using this framework, you can be able to trade or invest in different types of assets. The assets could be forex, could be stock, could be commodities, could be crypto. Doesn't matter. So I will go into this now. We start with the components of trading. So for those who have joined us uh, in this session for the first time, all the recordings of the video of the previous sessions are available on our YouTube channel, Asat Academy. Okay, you can go there and you can be able to find it, Asat Academy, ASAT, then Academy on YouTube. We have also our application. You can also go to asatacademy.ai. You can be able to also access the recordings from there, as well as download resources that you can use or to maybe practice later. Okay, so components of trading. There are three components of trading: the strategy, the psychology, and the management. So when you are buying anything, it doesn't have to be in the financial market. These three things always come into play. If you go to, let's say, a supermarket, you must have a strategy that tells you to buy a particular item. Maybe your strategy is to see what you are lacking, what you are out of in your fridge. Once you realize the thing you are out of, you would like to go and restock. That's your strategy. Okay. So if that is your strategy, you know what to buy. The same thing with trading in the financial market. You have to have a strategy that signals when you should buy a particular asset, sell as well. Psychology, this is your state of mind, your emotional state when buying or selling. That's your psychology. And lastly, the management. You have to be able to manage your money. You don't want to be putting all your money, for example, or even borrowing money to go and buy stocks. Okay. Okay. I think somebody is asking a question. Okay. Thank you. Thank you, Kata. So this is the management. You are trying to manage your resources. Okay. So that means when you are building a trading bot too, these things come into play. And how does that happen? We call this algorithmic process, right? Algorithmic trading when you are building a trading bot. So the trading bot will help us execute trades that will follow a certain strategy, and the strategy will define when to buy, what to buy, so that we buy at the best possible price. Okay. In terms of psychology, how algorithmic trading helps is it reduces the impact of human emotions. We humans, we have different types of emotions. Okay. So sometimes it could be hope, it could be greed, it could be fear, it could be overconfidence. So all these emotions come into play. But when you have robots doing things, these emotions are no longer a problem. Some of the benefits include speed and efficiency. Okay. So your system, you can develop systems that are very fast. Okay. When you have a trading bot, faster than human beings. They could be consistent because they follow a certain instruction. Improve my risk management. They do not take risks. Okay, in the case of human beings, we like to take risks sometimes, especially when we are overconfident. We just take risks thinking that we are invincible. That's not the case with bots. Backtesting capabilities, because data is available, these bots can go back in time. We humans, we cannot go back in time. So whatever strategy you develop, you can only test it against the future to see how it fares in the future. But if you have a trading bot, you can use the previous data and tell it, okay, yesterday's data is the history. Today's data that I already have is what I want you to predict. Okay, so now your bot has gone back one day. Scalability in the context that you can have many bots supervising and monitoring different assets for you, maybe hundreds, thousands, of assets is there watching, looking for opportunities. Once you have opportunities, they strike and execute the trade for you. If you are a human being, how many assets or yeah, how many assets can you monitor? But you have this army of bots, they can monitor as many as possible. All right. So when we are building, we always have tools. Okay. Now that we know of the components that we want to build and what are the tools? First of all, we are going to look at the tools we're going to use to build in this regard. I have what I call, this is something all of you, ChatGPT. Okay. So we are going to use ChatGPT, and then we're going to use Google Colab, Python libraries, and finally Alpaca API. I will talk about each one of these in the coming slides. ChatGPT. Why do we need it? It's because we want to build our strategies without having to code if possible. We don't like to write lines of code. Maybe we don't even know how to write lines of code. We don't know how to program, right? So ChatGPT can do that for us. All we have to do is to tell it in plain English, and then it will be able to generate the executable codes for us. That's why we want to use ChatGPT. Google Colab, okay, when we get the codes from ChatGPT, we want to run it. We want to run it in a programming environment. That's where Google Colab comes to play. It's free, and we would like to use it to make backtesting, to run our strategy using historical data to see how good our strategy will fare. Not only that, we would like to run complex simulations and models. Next is the Python libraries. Okay, so Google Colab uses it's a Python development environment, so it supports Python programming language. Therefore, when you are programming or developing in Python, you know that there are libraries that were developed by previous or other software developers. Okay, and these libraries allows you to simplify your coding process. So instead of building everything from scratch, it's like having spare parts or components. You go to the market, you want to build a car, you don't have to build the tire from scratch. You just maybe get the wheel, decide the size of the tire you want, and you go and you buy the tire and you install the tire. You want to get an engine, attach the engine, go, indicate the engine you want, get it, and come and plug. You don't have to build an engine from scratch. And these are the libraries, okay? So we are not building stuff from scratch. We will just use them and then we put things together and assemble them. Alpaca API. So why do we do this if we cannot be able to execute trades in real market? So you can say, then what is the point? And that's where Alpaca comes into play. Alpaca API is an API provided by Alpaca Securities. Alpaca Securities is a brokerage company in the US. Okay, so if you have used brokers before to execute trades, you know them, you know how they work. Okay, so Alpaca is one of those. You can also go and buy assets directly on Alpaca. Okay, I will show you the platform in the coming minutes. The API provides us with a bridge between our code and the brokerage account, so that if we run an order on our code, it should be executed in our account. That's the API. So we're going to use this API to be executing orders from our coding environment and get it executed in the Alpaca account. Okay, so these are the tools. The next thing is to talk about the components of every trading strategy. Okay, not just algorithmic trading bots, but every trading strategy comes with these components. The first thing is the signal. How do you tell when to buy or when to sell? You have to know when to go into a trade. So how do you spot a trading opportunity? That's the signal. After you spot the trading opportunity, When are you buying or when are you selling? That's the order type. Are you buying immediately on spot whilst you figure something out, or you're going to delay and wait for some time? So if you are buying immediately, that's the market order. If you are waiting till maybe the price comes down so that you increase your profit margin, that's limit order. If you are waiting for the price to start rising or falling to the prediction you made, so that you now become more certain that your predictions are right, that's called a stop order. Okay. There are different types of orders, not just these three, but these three are the major ones. You have the limit stop, trailing stop, and so many of them. So the risk management is the last part or the last aspect of trading strategy. This comes with telling you, okay, now that you are in the trade, how do you get out? Are you going to stay here forever, maybe allow your grandchildren to come and inherit it for you, or you going to go out when something happens? So that thing that could happen could be one of the two, right? Either the price of the asset reaches your prediction and you take your profit and you go home, or you lose all your money, or you buy that asset and lose all your money. But we don't want that to happen. We want at least to have some level of protection. We don't want to lose all our money. We want to make sure that out of our money, we are willing to, let's say, lose a certain portion of it. So that's the stop loss. Position sizing, this indicates the amount of money you are willing, or the part, yeah, the portion of your total account which you are willing to use to get into that trade. Let's say you have $10,000. Are you going to use the whole 10,000? Are you going to use 50% of it? Are you going to use 10%? That's the position size. So you have to indicate this when you are building a trading strategy. Based on this, you can be able to also automate it. You have these things, you can automate your strategy. Okay. So how do we get the signal? And this is where machine learning can help. Okay. What we said here is we're going to use something called regression analysis. I discussed about the regression classification as types of what? Supervised learning approaches. So the regression analysis here is simply to say, okay, given independent variables, okay, let's say the MACD, you know, the moving averages, RSI, ATR, all these indicators, or if you are into fundamental analysis, you can say, given, let's say, the PE, price to earnings ratio, what is going to be the price of Tesla stock in the next 1 hour? Okay. Or it could be maybe given news or the sentiment of the people about this particular stock. Maybe you are reading news, you are reading social media, you are seeing people talking about a particular stock, people are excited, people are happy, then you also buy in. That is your own variable that makes you make that decision. And because of that, you try to say, okay, given the amount of, I think, positive reviews I'm seeing, most likely Tesla is going to reach $1,000 a share. So this is a regression analysis, and it comes in two shapes: simple, and multiple. So when you are dependent on only one single variable to make that decision or prediction, we call this simple regression. But when you have two or more variables that make you come up with a decision or prediction, we call this multiple regression. For example, if you have the MACD, ATR, interest rate, inflation rate, so many things to come in, use this to be able to come up with a decision of the price prediction. You call this multiple regression. Okay. So now we're going to do regression. Agreed, fine. There are different types of regression techniques out there. Lots of them. Okay. Last week we looked at linear regression as a technique. All right. Today we are going to see how neural networks can be used to do regression. They can be used to do regression, these neural networks. And as we said, what do they do, neural networks? They get in inputs. In this case, for example, the RSI, and based on the RSI value, it goes through the neural networks, all those, neurons and connections, all of them. It goes through them, for example, multiple layers of them, for example, all of them connected, and then they give you out a function, which is, of course, in this case, the price. Okay, so that's what we want to do. So that's what they do. That's what neural networks do. So, what are, for example, if I'm trying to predict house price, what could be some inputs, some of those variables that will let me decide how much to value a particular house? Okay, maybe the crime rate of that neighborhood, you know, the property tax rate, the local property tax rate of that neighborhood, average number of rooms per home in that neighborhood, distance to highway, and lots of them. In this, there is a data set we call house data, Boston house data set. It comes with around 23 different variables. So 23 variables are used to determine the price. So you can see, if you are a human being, how many of these can you keep track of, as a human being? Maybe three or four. You can be able to figure out the pattern between these three or four to determine the price. But once the number of variables reach like 7, I think you can no longer easily figure out a pattern. Okay. So as I said, this will come, okay, not 23, 13 features. There are 13 features. Okay. There are 13 of them. They come in and all of them are connected to neurons. Remember, these are neurons. Okay. So many of them. That's why you see these three dots. And then at the end, you get the home price. So similarly, with the prediction here, okay, we want to see, we are trying to predict what is going to be the price of Tesla in the next 1 hour, okay, of Tesla stock, for example, in the next 1 hour. So we give it all the RSI, you know, simple moving average, exponential smoothing average, you know, whatever, MACD, all of this, we give it all these values, the current open price, yesterday's okay, last hour's closing price, the high price, the low, all this you give it. These are the futures. Based on that, it tells you, okay, Tesla is going to be 300 next hour. Okay, so this is what you want to use the neural network to do. So what is our objective? Simply use those historical data, use the historical data to predict the price using neural networks. That's our objective. And what is going to be the logic? The logic is simple. We are going to predict price. Okay. So once we predict price, once we get our let me call it prediction, and then we have the current price. Okay. Let me change it to current price and the predicted price. Okay. So let's say the current price is 200. And then we pass all the information of MACD, everything to our neural network, and it tells us that in the next 1 hour, the predicted price of Tesla is going to be 300. So that means current price, let me call it CP, is less than the predicted price PP. For this, I will go long. Okay, so this is scenario 1. Scenario 2, the current price is still 200 and the predicted price is 150. So since the current price is greater than the predicted price, I'm going to go short. Okay. Scenario 3. So 1 and 2, I am not in any position. I did not buy before. I did not sell before. Maybe this is the first time I am even checking. Okay. My first check of the day, early in the morning. I didn't buy. I didn't sell anything. So I just come and I do just this simple test, and based on that, I execute my trade. I go long or I go short. Okay. A simpler scenario is also a similar scenario could be, okay, maybe this is the first hour. Let's call this hour 1. Okay. Hour 1. Okay. So this 2. So let's go to hour 2. Let me use a different color. Okay, so this is our 2. Okay, so we will have 3 and scenario 4. I will put them down. So for scenario 3, in the second hour, the current price, let's say, is 220. Okay, but the predicted price is still 300. So remember, I already bought Tesla in the previous hour. Since I am already inside the trade, okay, and still my prediction is way above the current price, okay, so I'm supposed to go long. Should I buy another Tesla again? I already have, let's say, one share previously which I bought because I got this decision, and here, you know, should I buy again or not? So what I did in my case was, do not buy, just hold on to the one you already have. Do not buy in more. Do not buy more. Stay, hold out. Okay, hold on. The fourth scenario is the current price is 220, for example. Okay, I predicted it is going to be 150, and it still remains at 150. I sold before. I was in the sale, you know. So you can see when I bought it, it was 200. That was when I bought it, right? It was 200. Now it has even increased to 220. So that means things are going off. It's still telling me to go short, but it's still telling me to go short because 150 is less than 220. So I'm already in the short position. Therefore, I will continue to stay in the short position. I will not buy another Tesla saying, okay, if I buy Tesla now from 220 to 150, my profit margin has increased by 70. I'm not going to go into that. Unless if I have maybe a stop loss that said maybe at 210, take me out of the trade. Then I will go out of the trade. Now that I spot the opportunity, I come back in. So this is my simple strategy. There is another scenario though. Okay. So this scenario is saying when either of this, none of this is happening. So what should I do? I shouldn't do anything. Don't do anything, you know. Or when we have another scenario, I already predicted that the price is going to go to 300. When I bought it at 200, my prediction was it is going to reach 300. But then now in our 2, the prediction was not 300. But now the prediction is, let's say, 180. Ah, you are predicting 180. That means you are even predicting below the current price. The current price is 220, but you are telling me it's going to be 180. Based on my logic, since 180 is less than 220, I'm going to sell. I'm going to go short. So this I call it trend reversal. Everything has now turned upside down. For that, I will just sell. I bought it at 200. The current price is 220. I will just sell and get out with my $20 profit because my linear regression, oh sorry, my neural network is telling me if you wait till the end of the hour, this 220 you have now is going to go down to 180. Are you going to wait or are you going to take your profit and go? Okay, so that's what I'm doing. So these are the logic in my strategy, and I will explain all of this to ChatGPT. Okay, so what is my order type? The order type is simple. Once I spot an opportunity, I'm going to buy. So I'm going to use the market order. I get an opportunity, I buy immediately. Risk management. How do I intend to manage my risk? First of all, position sizing. I'm not going to put more than 2% of my money. Okay, 2% is the maximum I'm willing to put for every trading opportunity. So if I have 100,000 or let's say $10,000, I'm willing to put a risk $200. Okay, that means if I also define my risk to reward ratio as 1:2. Okay, this is my risk to reward ratio. That is, I'm going to go and I will be willing to lose 200, but then I should be able to make 400 if I am right. If the neural network prediction is right, I want to make sure I make 400. If the neural network prediction is wrong, okay, don't lose more than the 2% that I am given. So this is going to be my risk management. So when I see a trading opportunity, let's say I see Tesla at let's say 200, okay? So I have to see is my So I will put my TP, for example, plus the this amount, which is 400. So I'm not going to sell until when Tesla reaches 600. Okay. Okay. This is for example. Let's even call Tesla to be 500. Why not? Okay. Tesla is, let's say, 500. Okay. So Tesla is 500. I want to make 400. So that means I will take my profit at 900. Okay. My stop loss is Tesla is 500. I'm willing to lose 200. That means my stop loss will be set at what? 300. So once Tesla drops to $300, I'm going to get out of the trade. I lose my 200. Once Tesla reaches $900, even if the hour has not ended, you get my point. Even if the hour has not ended, I'm going to sell. Okay, even if we are in the middle of the hour, or even if it is just 1 minute after make I execute the trade, and then it shoots to 900. I take my 900, I get out. I'm not going to say, no, 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 it is shooting up. Let me wait till it reaches 1,500. I'm not going to do that. Okay. I'm just going to follow my risk management strategy and get out. And the other part was, if, for example, I'm predicting 900, then the prediction, okay, the prediction is less than 900. Let's say the prediction is telling you that Tesla in the next 1 hour it is going to be let's say 200. Okay, 600 for example in the next hour. So Tesla is going to be this. So what I want to do here is simple. To say, okay, if that is the case, that means the difference is not 400. The difference is just 100. Okay. So my take profit, I will set it to 600 because that's what neural network is telling me. I will obey neural network. And then my stop loss will be half of this. So I will put 50. So if I lose 50 here, once Tesla drops down to 450, I will get out of the trade. So these are my risk management strategies. Simple as that. Okay, so this is the maximum I'm willing to make is 400. Maximum I'm willing to lose is 200. Okay, but what I'm going to put for my TP is going to be dependent on the prediction of the neural network, and the stop loss is going to be half of the prediction price. But these are the maximums. Okay, assuming the prediction is telling me 10,000, Tesla is going to be 10,000 in the next 1 hour. For me, I will just go to 900 and I will get out of the trade. I'm not going to wait till I reach 10,000. Okay, this is my risk management. Okay, so that's the idea. So the idea is we're going to follow this framework. We will start with environment setup. We will discuss this trading strategy, okay, to ChatGPT. Once it gives us the go ahead, then we will build a machine learning process. We will test the strategy using historical data. Then we will connect to the market and we will automate our trades. These are the 6 steps. For the case of the machine learning process that is in between, we're going to follow these following steps. First of all, we will collect the historical data, we will collect it, put it together, we will prepare this data, then we will pick a model. After that, the model, of course, here we are talking about the type of algorithm. In my case, I'm using neural networks. Okay. Then we will train this neural network. As I said, the training is the act of tuning those weights. Telling us which of those inputs, this RSI, should I give more influence or more significance to, or it should be MACD. So that is the tuning aspect. That is the training aspect that will allow me to have as little error as possible. Okay. After I finish training, I want to test. I want to evaluate the performance of the model. If the performance is good enough for me, I'm happy. If not, I will tune some few parameters to see what happens. So we have so many parameters, like having a car. You have the engine. Maybe you try it with a V6 engine and you are not happy. Then maybe you turn it to V4 or V whatever. Try it to see what happens. Are you getting the results you want? So these are the parameters we tune. Okay, So let's start with the bot building. So before I go into this, I think if there is a question you can ask now. I think I've spoken for almost an hour. So if you have any question you can ask, you can send your question in the comment in the chat, or you can open up your mic and ask. No worries. All the same. Okay, I assume there are no questions. Okay, how can I get link to the recording? Okay, you can, as I said, you can go to our channel on YouTube. Okay, Start Academy, or you can go to our app.ai in the same as Start Academy. Okay, so once you go there, you'll be able to see the workshops we have, the previous ones. They are all available on both YouTube and the app. You can be able to download or watch the recordings from there. Okay, any other question? All right, you are welcome. Okay, so let me move in. I'll stop sharing and I will share my other screen. Okay, so as you can see here, we have our tools up and running. We have Alpaca, which is our brokerage account. We have ChatGPT, okay, and we have Google Colab. These are our three tools. This Alpaca, as you can see here, you can place trades. As you can see, I have some trades ongoing. All these are trades we executed during our previous classes. They are still running. I didn't stop some of them. They are still running. Yeah, I started with 100,000 and I don't know, we are losing money or something. Yeah. Okay. All these are the orders we executed and what have you. So if you scroll down here, this is where you can buy manual. For example, let's say you want to buy Amazon. Okay. I think it's AMZN, right? This is the ticker symbol. Okay, this is the price. I can indicate I want to buy immediately. Market order. Let's say I want to buy 10 shares. Okay, 152. I will say review, confirm order. Order created. Let's see the list of orders. Yeah, here it is. Amazon accepted few seconds ago. I can go ahead here and cancel this order that I just placed. Just press this, cancel, confirm. Okay, so this is doing it manually. Okay, it has been cancelled few seconds ago. You can open the chart. You will be able to see the chart. Okay, this is Alpaca, and you can see all those indicators. Okay, you can have so many of them. You can place them. For example, the ATR. You can place the ATR indicator. It is still loading the chart. You can put the RSI, for example, RSI relative strength index. Okay, so you have them. You can add your moving average, simple moving average, for example. There is adaptive moving average. Add it. So when the chart is up and running, you'll be able to see all these indicators. You're still loading. Okay. So this is how you do it manually. All right. You can buy, you can sell, no problem. For you, if you want to use automation, there is the API keys down here. You will see in your case, in my case, I already generated them, so I will just view them. I will just click view. In your case, you will see create API keys. So you create API keys, and this is the first time you are opening an Alpaca account. So you will generate the keys, you will have endpoint key and then secret. There will be three different values. Make sure you get them right. Save them because the secret is always going to be left out when you view them. So make sure you save them in a Word document. You need them for later. This is what you will use to connect your account with the code. Okay, so this is a little overview of Alpaca. Okay, the next is ChatGPT. I do not need to tell you about it. You already know. And then we have Google Colab. This is where we will be putting our uh, our codes. So just go and put colab.research.google and you should be all right. Okay, so what should I do? Starting, the last thing that you are not seeing here are the libraries. Those are the components or the spare parts I was talking about. All right, so we will install them. That will be the first step, right? Environment setup. You look at this, you see our first step is environment setup, which is what we're going to do. So I will start with installing all those libraries to make sure I have them. Okay, then after that, and add, maybe let me call this step 1. Install libraries, for example. So all the libraries will be installed. Okay, oh no, sorry, the environment setup. Okay, it will be installed. In the step 1, everything is done. You can see the tick. Okay, so the next step is for me to test my Alpaca environment. Okay, so I need to do that. So I will tell ChatGPT that I want to do that, and it will provide me with the code. So I'm going to tell it I want to build a trading bot that will trade Amazon stock. I want to use Alpaca API to connect to the market. I've installed all necessary library requirements. I'm using a paper trading account to test my strategies. To test the connection, start by executing a market order on Amazon. Let the trade run for 10 seconds, then cancel the order. So this is what I'm telling it already to do. Okay, so I can wait and allow this to finish generating the response. And you can tell it to stop telling you all this. So the next step will be the machine learning process. Okay. Okay, I got the codes here. Told me you need to ensure that you install Alpaca. I already did because I installed all libraries. So I will copy this code here. I will paste it here. But it is telling me here, replace your API key and your secret key with your actual Alpaca keys. I already have them. Okay, so I will copy them. As I told you, if you go to Alpaca here, you will see them. You go down. Okay, this is my key. Here I will copy this one and I will paste your secret key. You can get it. I already saved it in a Word document, so I will copy and paste. Okay, so let's see. I told it what to do, right? I want to test connection. So I will run this. Okay, order placed for Amazon stock. Let's see. Is order placed on our Alpaca? Aha, accepted. You see it coming up? This one. Order will be cancelled now. You will see this will change. I know there is a little latency. Just have to be patient. Cancelled. You see? So we have established connection. I can maybe try a different asset, maybe tell it to do Tesla and stuff like that. Okay, so we are happy. We are finished with the first step. Okay, which is this one here. So the next step is to build the strategy. Okay. So to build this strategy, normally all I need to do is to talk to ChatGPT. Okay. So I will tell it my strategy, which I already have written down in Microsoft Word document. Okay, so this is what I told it. And it's exactly what I explained to you guys. I said my objective is to use deep neural networks to build a trading strategy using regression analysis. If I am going to go long, this is my trading bot logic generated when the current price is below the predicted value, suggesting undervaluation. Going short, generated when the current price is above the predicted value, indicating overvaluation. Okay, so this is when I go long and I go short. This is my signal, right? And at the completion of each candlestick, feed the latest data into the model, get the prediction, okay, which is this, then do comparison. If the prediction is to go long and I'm not holding any position, that's why I said currently no position, then buy. Let's say that is the first time, okay, that's the first candlestick. Okay, set TP at the predicted price, just as I told you, by the linear regression model. Okay, this is not supposed to be linear, by the neural network. Okay, then set the stop loss according to risk management rules. As I told you, risk management is here. We'll come to it. This is it. So this I told it all the things I explained to you. And then the next thing is the market order. I told you the order type should be market order. The risk management, assume my initial capital is 10,000. My risk is appetite is 2%. Okay, stop loss, set stop loss, maintain this risk reward ratio. Okay. So I told it the next step is the machine learning process. But before I go there, let me know if you understand this before we move to the next step. And that's what I told it. So it said, yeah, it's clear and well defined. This is what I need to do. Okay, set take profit at the models, predicted price, set stop loss at this. Okay, enter position, do this, order type this. So next step is asking me for it, and I will provide it with the next step, okay, which is the machine learning process. Okay, so this is what I said: generate code to execute the machine learning process, data collection and pre-processing. This is the first step. Use Yahoo Finance to get 1 year data. I want the open, high, low, close, and volume for the stock. Get my microeconomic data. I want to add another thing like inflation rate, interest rate into the mixture. Don't combine this now because I want to also get technical indicators, for example, ATR, RSI, MACD, and also moving averages. Okay, and I want to use the TA library. After that, integrate inflation rate and interest rate into the data set. Normalize or standardize the data. Ensure everything is synchronized, sample to match the 1 hour interval. Structure everything as a data frame. The regression, the labeling is you are predicting the next hour. What is going to be the price in the next hour? That's what I told it. And I'm going to train a deep neural network model with 2 hidden layers. Okay. And I'm going to use the Keras library. I want to evaluate the performance using the relevant performance metrics. So it is giving me the code. So I will copy this, I will paste, we'll start getting the data. Of course, I might get some errors. If you get errors, just bear with it. Okay. Talk to ChatGPT and everything. Okay. For the sake of time, I will just move to the next step. And you are able to come in the next session. We are going to go deeper and also talk about everything accordingly. Okay, so after that, what's the next step? To test the strategy. Okay, so I will write the code, test the strategy. I will ask it to get me the code. So what did I say? I said awesome. Next, I want to backtest the strategy I described above using the trained neural network. So we have finished training, assuming everything works. Okay, and I want to use it and the collected data over the past 1 year. I want to print the total number of trades. number of times I go long, and number of times I go short, number of times I hold my trades, number of times I didn't trade, the return in percentage, and the return in dollar. Assuming my initial account balance is 10,000. Okay, I started with $10,000 and I maintain the risk management I mentioned in the strategy. Write me the code to simulate the strategy on the historical data while recording its trace outcomes. Lastly, evaluate the strategy based on profitability, maximum drawdown, win-loss ratio, and other metrics. Use functional approach to build the code so that we can use the parts during the deployment in real market. So it will write the code for me. And once it is done with that, the final steps will be to connect to the market and to automate the trades. Okay, so that's what we're going to do next. So I will just allow it to finish everything, but for the sake of time, those who attend this session, if you come tomorrow, we will discuss this further. We will add some few things into this and have a full walkthrough of this. The main idea of this first session is to give a very well and comprehensive discussion and overview of reinforcement learning and deep learning. Okay, so I gave it these 5 and 6 steps here. I told it, okay, uh, connect to the market. I want you to adapt the back testing code using modular approaches. Okay, using that, then connect with the APIs for real-time data and order. Okay, then automate and execute the trades. Okay, this is the step 6. Trade execution logic. Implement the logic to execute trades based on the model's prediction within the trading hours, ensuring all positions are closed before the market closes. Start with a framework, then ask for the parts and everything. So all these prompts that I have here written in my Word document are going to be provided. All right, they are actually made available on the application. If you look at my previous workshops, the code, the working code, the prompt, even the lecture notes are all provided there. So make sure you visit our application. Okay, so that's what next. So this is what we are doing now. We have done this. We've seen how to build it. Even if you do not attend the session, if you follow this approach and download the video or watch the video with the codes and everything, you should be able to follow along. So we are in week 3, where we are using reinforcement learning and deep learning. In week 4, we are going to use natural language processing. So we are going to build a bot that can also read news, okay, to tell if there is good thing about a particular, you know, about a particular stock to buy or not. How to get resources? Our YouTube channel, Asat Academy, as I said. Our app, download it. Everything for now is free. We are not charging because we want to get feedback from our users. So you can use it for free. And please provide us with the feedback if you are using it so that we can keep on improving the app. For those who need additional assistance, you can always book a 30-minute free call with me and we can go through your issue. Okay, I will paste the code, the link for the meeting booking. Okay, it's there in the chat. You can book a meeting with me one-on-one. We can discuss further. If you want to build a trading bot or you have an investment strategy that you want to automate, you can reach out to me. Or if you want to learn about AI and stuff like that, also you can reach out to me. Awesome. All right, guys. Thank you for being here. I really appreciate it. Hope to see you tomorrow. Take care.